after achieving two learning objectives in the first two videos, now we're going to talk about determining infinite limits at infinity. So this learning objective is slightly different from the first learning objective because the result of the limits in the first learning objective were finite, but here they're infinite. So then you're going to try to understand what's going on. All right, so let's start. So I'm going to talk about infinite limits at infinity. I'm going to start with the official definition of the infinite limits at infinity. So this part of the lecture notes, only this slide, and the discussion around this slide within this video is only for honors section. So if you're not an honors section, you can disregard this slide together with the discussion about it within this video. But I'm going to show you an example in a few minutes, so all students are responsible for that purpose. So let's start with the definition of infinite limits at infinity. Let's say like we have a function defined on the open interval a and infinity. So we're trying to understand what means to have a limit of f as x approaches infinity to be infinity. Okay, normally we conclude this is like doesn't exist, but let's say like this is positive infinity. So what is the meaning of that? So the meaning of that is like there for any given positive number m, there exists another positive number n depending on that, so that whenever x is greater than n, the corresponding function values are greater than n. So this is an example of a function increasing without bounds. Okay, so no matter what m you provide, there's always an n, capital N, so that whenever x is bigger than a number, so that the function values are going to be about y equals m horizontal line. And the same thing is valid for the limit spitting out negative infinity as x approaches infinity. So what that means is that for each negative number m provided, there exists a positive n such that whenever x is greater than n, the corresponding function values are going to be less than m. So this is an example of a function decreasing without bounds. Okay? And similar definitions can be provided for infinity type limits as x approaches negative infinity, and minus infinity type limits as x approaches negative infinity. Okay, so again, this is only testing the honors section students. So if you're not, just disregard that. All right, let's apply this concept to the example, and all students are responsible for this part. So one question is asking about the limit of x cubed as x approaches infinity. And the other one is the same function, but we're looking at behavior as x approaches negative infinity. So essentially, you can technically plug in infinity in just to see what the sign is when you cube it. So essentially, when x approaches infinity, so x gets bigger and bigger without bound, and x cubed is going to do the same thing, right? If x is getting bigger, x cubed is going to be getting bigger as well. So for that reason, the limit is going to be infinity. Or you can also do this. You can just substitute infinity as if infinity is a real number, just to have a reality check. So infinity cubed is still infinity because a large number raised to the power of 3 is going to be another large number. And you can see this approach in the next example better because in this one, x approaches negative infinity, right? So then if you substitute negative infinity, so negative infinity cubed is going to be negative infinity cubed, right? So negative infinity cubed. So what that means is infinity cubed is already a large number, so it's going to be negative infinity. So you can also do this like substitution in a very informal way, treating infinity like a real number, which is not. Okay, and you can graph this function, and for small number for x min, okay, for a large number for x max, and you can easily conclude that as x approaches infinity, the corresponding function values are shooting to infinity, and as x approaches negative infinity, the corresponding function values are shooting down to negative infinity. All right, it's time for practicing all three learning objectives. Please go ahead and open the PowerPoint file for the recitation of 4.5. I have 3 questions in total in this series. The first question is about the first learning objective, which is using the skill set of the first learning objective. You can approach this question in three different ways. One is the table of sample values. Second is having the graphical aid, your calculator, in graphing this function for large values of x. And eventually, you can also use some rigorous ways meaning algebra, to handle each limit. And I mentioned that in the first video. Please go ahead and check that. And you have all three different versions of functions here. So the second example is a very interesting one. You're trying to find the limit of x times tangent of 1 over x. And this is a kind of question, you have infinity times tangent 1 over infinity, so infinity times tangent almost like 0, which is infinity times 0 type indeterminate form. So to be able to handle that, there is a substitution or change of variable, however you call it, change of variable to convert this limit problem into another limit problem for which you can apply other tools. I would totally recommend you to watch the video. There's an interesting stuff going on over there. And finally, you have the difference of two functions, and if you pass the limit right away, it's another indeterminate form you get. It's infinity minus infinity type indeterminate form. And one way to handle this problem is, in fact, rationalizing the numerator here. And in fact, you will see that you're going to multiply this function here, 4x minus the square root term, by its conjugate and divide by that. And you will see that there's some nice form popping that's going to make infinity minus infinity disappear, but you're going to have something else. Anyway, I don't want to give you more heads up, but please watch each video and practice the content. All right, as I said, we're completely done with all three learning objectives. I'll see you in another video. Bye.